In this video, we will learn how to create the exterior of a project. For this specific project, we've actually created the exterior to a certain point, and now we will learn how to model the elevation. So far, as we were working on this project, you realized that most of the exterior of this building we're working on is just glazed all around, and more specifically, it's all curtain walls. So for the exterior of this project, we're only using curtain walls all the way through. Now, what do I mean by finishing the exterior and modeling the elevations? You see, while we were modeling the curtain walls for the exterior, if you recall, we also made sure to place all the mullions that we needed, and we positioned them all in the right places. So basically, when we drew, for instance, this curtain wall over here, we also adjusted the settings for its mullions, and we placed them in a way that they were completely matching with the CAD plan. So according to the CAD plan, we also placed them all in the right places. So up to this point, the exterior of our building is pretty much finished. We've got the curtain walls, the mullions, and it seems like there is no problem. But the thing is that you need to always check out the exterior that you are given in the CAD plan and see some other changes that you need to make to your model. So like if I go over here and open the CAD plan for this current project we're working on, you will see on one side we've got the floor plans, and on this side we've got the sections and the 4 main elevations of the exterior. So now if we zoom in on here, we will see that, for example, for this ground floor, although we have correctly placed the curtain walls, the appearance of the curtain walls used in this level are very much different from the ones in the other floors. The main difference between them lies in this part. As you can see, the curtain walls of this ground floor are into 2 pieces, and so they have 2-piece panels. Now, as for the materials of each of these panels, your client will tell you about that. For example, when we were working on this project, we were told that this lower panel was supposed to be glazed, and as for the panel above it, which is indicated by these yellow boundary lines, this one was supposed to be solid. Basically, it's non-transparent. And so basically we just had to go back in here and see the other changes that we needed to make to the model. In the first step, we only drew the curtain walls, and the process is going to be pretty much the same for the other floors. Like if I show you the Revit file, here you can see what the curtain walls look like. It's all curtain walls all around, going all the way up, whereas it shouldn't look like this for some parts. Like some parts shouldn't have just straight up vertical partitions, and they might need to have horizontal panels as well. You could identify such changes that need to be made by taking a look at the elevation and then apply them to your drawing. Or for example, if you take a look at this one, this is the south elevation. Here you can see some elements that we have not yet used in our project. So basically that's how you have to model the facade of the building. You'll just have to take a look at your AutoCAD elevations, and then you make the exterior of the project based on those plans. So essentially, this is what we're going to be doing in this session, and it's actually not very complicated, and it's basically just regular modeling, only we're going to need to make some changes to the curtain walls or any other exterior elements. Now also remember that we're not going to be making our exterior by looking at all the elevations. For instance, this one doesn't seem to have too much that needs to be focused on. I've only picked some elevations that we're going to use for this session, which also happen to have some important details, and so it would be better if we started with those. For example, look at the south elevation. Just the way that we're going to be creating and placing this wall is alone a very important point. Or for example, this one, which is the west elevation. Although we seem to have only some curtain walls in this one, but there is also this entrance to the left, which has a different type of curtain wall. And then there's the ground floor, also with a different curtain wall type from the other levels. And so these are the things that we're going to be focusing on and applying to our project. So if you would agree, let's begin. Now you probably already know that before we begin with the process, the first thing we need to do is to take this elevation and import it into our Revit file. Then we would align these grids with the Revit grids and to see if they will be aligned with each other. For some minor details, for example, the fact that the curtain walls on the ground floor have 2 different panels, you could just measure their dimensions in AutoCAD, then go to Revit and edit your curtain walls if necessary. Then at the end, you will import your elevation into the west elevation in Revit and see if everything will be aligned together and if the elevations will correctly fall onto each other. Because you see, when we model our projects using the BIM methods, we would have to double check every single thing and make sure it's correct. Generally, I would have to import this elevation in Revit and to first see if the elevation I have drawn for my plans in Revit is exactly coordinated with this one or not. Maybe the position of the mullions are different, and if the drawing and the elevation are contradicting, I would have to report it. Essentially, this is how BIM works. You will have to report all the clashes and any misalignments in the project, and let your client know before proceeding. That way, the project will go further faster, and it would even cost less to model and construct. So we're going to have to check everything, as in every single file that we are given, no matter if it's AutoCAD, a PDF file, or anything else, those need to be checked with your drawing, and to see if you are drawing correctly according to them. And for instance, if you import this elevation into your project and see that your drawing differs from it, then you'll need to check two things. One is whether you've drawn correctly or not, so then you'll have to double check the plan and see if the modeling error was from you. But if that weren't the case, then it would mean that the plan has some issues and it needs to be reported. So you'll have to discuss this with your client and see which one should be prioritized and whether you should follow along the demonstrations in the elevation for your modeling, or if you should go based on the position of the mullions in the plan. So those need to be checked, along with anything else that you're not sure about. Alright, so I will begin with this west elevation. I will begin by first selecting this whole drawing and putting it into a different file. That's the same thing we did for the plans. So I'm going to take that drawing into a new blank file. You see, now if I import this plan into Revit's elevation, I would need a mark to be able to align them together. The marks are usually the levels and the grids, and we only have the levels, so that means I'm going to have to bring along its grids as well, so that then I could precisely align it with what I already have in Revit. So I'm going to go back in here and reselect the drawing, this time with the grids. And now I'm going to go over here and I'm going to place it somewhere near the midpoint. So for example, if you place it over here, then you'll have to look around Revit to find it, because then it would be far from the 0 point. So that's why I recommend that you position it somewhere near the 0 point. And as for these, I'm not going to need them, so delete. I'll just try and declutter the plan a bit so that I can import it easily. We don't need this tree, and we just want to have a lighter file in size. Now we're going to save this. Going over to our files directory and save it in this folder. And we're naming it West Elevation. Alright, we're saving the file. Now we're going to head over to Revit, then open the West Elevation. And then here is where we will import our AutoCAD plan. The first thing I'm going to do is I will turn off the crop region for this area so that I will be able to see the entire elevation. Also, keep in mind that in the 2025 version of Revit, there will be scope boxes defined by default for your plans, which you will first have to set to none, so you would have control and access to the crop region and be able to turn it off from down here.